All right, so here's our video for half angle formulas. I want you just to take a minute and look at them. We have a sine formula, a cosine formula, a tangent formula that involves a square root, and then two tangent formulas that involve just fractions. So these are called half angle formulas, because we'll take some angle from the unit circle and then divide it by 2. So what I mean by that is this first problem is asking me to find cosine of 15 degrees. Now 15 is not on our unit circle, but there is an angle that divides by 2 to get 15, and that angle is on our unit circle, and that is 30. So think about cosine of 15 is the same as cosine of 30 over 2. Now 30 is in the position of this alpha, right? So alpha over 2, alpha happens to be 30. So I'm going to go to this cosine formula, and everywhere I see an alpha, I'm going to substitute in 30. So this becomes plus or minus the square root of 1 plus cosine of 30 over 2. So I go to my unit circle, and I determine that cosine of 30 is rad 3 over 2. And then this is all over 2. Oh, and I wanted to write up here that alpha is 30. Now, inside here, I need to combine these two fractions. I'm going to rewrite this one as 2 over 2, right, so that I have common denominators. And then I will combine these two fractions into one with a denominator of 2. My numerators are 2 plus rad 3. And all of that is over 2. Now really this 2 in the denominator is over 1. So I'm going to keep change flip. So plus or minus 2 plus rad 3 over 2 times 1 over 2. And that becomes plus or minus 2 plus rad 3 over 4, because when you multiply fractions, you go across the top and bottom. I would accept this form as an answer, but also understand that it's not rationalized in the denominator. You can break this fraction up into 2 radicals, and that bottom simplifies to 2. Okay, so then number 2, sine of 105. Again, 105 is not on our unit circle, but we do have an angle that when divided by 2 would give me 105, and that is 210. So that means that our alpha value is 210. And I'm looking for the sine, so I'm going to go to the sine formula, and everywhere I see alpha, I'm going to plug in that 210. So plus or minus the square root of 1 minus cosine 210 over 2. And I go to my unit circle, and I determine that cosine of 210 is negative rad 3 over 2. Now, minus a negative becomes plus plus. And if you notice, this math is the same as this math we did over here. So I'm not going to do that again. And then you pause the video and try number 3 by yourself. And you can use any of these 3 tangent formulas. I recommend avoiding this one if you can, and trying one of these right here. So pause the video and try that. All right, I chose to use this formula right here for tangent. So 75 is 150 divided by 2, so that means my alpha is 150. So I plugged 150 in wherever I saw alpha in the formula. That gave me 1 minus a negative rad 3 over 2. Minus negative becomes a plus plus. I rewrote 1 as 2 over 2, so my denominators would match. Then I combined that into one fraction with the denominator of 2, and then I had 2 plus rad 3 in my numerator. Then I did keep, change, flip, so keep the top the same, change to multiply, flip the bottom, becomes 2 over 1. Those 2's cancel. I multiply across the top and bottom, and I have 2 plus rad 3. Now on the back, we have two different sections. On this first section, we're working the formulas backwards. So we're looking at what we're given. I have radical 1 minus cosine over 2. So I'm going to come over here, and I realize that that is the formula for sine, 1 minus cosine over 2. So I know that this was using the sine formula for some alpha over 2. Now the way I figure out what was replaced, or sorry, what was substituted for alpha is whatever's right here. Because in the formula, that's where my alpha is, cosine of some angle. So by looking here, I can tell that that angle was 60. So that's my alpha value for my half angle sine value. So 60 over 2 is 30. And then I just go to the unit circle and I find 30. And the sine is the y value there, which is 1/2. Right? You pause the video and try this one, number 5. All right, so hopefully you came up with cosine of 120 over 2, that was the cosine formula, which is cosine of 60, which is the x coordinate there, which is 1/2. Okay, down here in this section, we have something that works a little bit differently. We're being given this information that cosine alpha equals -3/5, and that alpha is somewhere between pi over 2 and pi. And we're being asked to find these values. So notice we don't have an actual angle value, but here's what we do have. We know that the cosine of whatever that angle is -3/5. And if you notice on these sine, cosine, tangent formulas, not these on the right, but these here on the left, for all of them, you only need the cosine value in order to evaluate the formula. So we actually have enough information. If we were to use these over here and we needed the sine value, we would have to do some triangle math. We would have to do Pythagorean theorem because we're given x over r. We would need to do Pythagorean theorem to find y. So we could do y over r for sine. But we don't need to do Pythagorean theorem math here since all the formulas just need cosine. So I'm going to do one for you and then give you a minute or ask you to pause the video and try the other two. So for this first one, cosine alpha over 2, we're going to be using this cosine formula, square root of 1 plus cosine alpha over 2. So there's the general formula, and we know that cosine of alpha equals -3/5. So I can substitute these two things in for each other. So 1 plus -3/5 over 2. So this is going to be a keep, change, flip situation where I have to rewrite 1 in the numerator and then combine these two fractions. So I'm going to rewrite that 1 as 2 over 2, and then plus a minus, or plus a negative is minus. So now I'm here. Sorry, I'm going to rewrite the 1 as 5 over 5. So now I combine, so I'm in the numerator, I combine them into 1 with the same denominator, and I do the math on the numerators. So 5 minus 3 is 2, the denominator is 5. That is divided by 2. So I'm going to keep, change, flip. remember that this 1 in the denominator, oh, sorry, I'm trying to rush, so now I'm making mistakes. That this 2 in the denominator is over 1. So when I go to keep, change, flip, it looks like this. Keep the numerator the same, change to multiply, flip the denominator. Now these 2's cancel, multiply across the numerators and denominators, and it's plus or minus 1/5. We are accepting this answer in this unit, but also if you were to rationalize the denominator, you'd have plus or minus rad 5 over 5. All right, so I want you to pause the video and try 7 and 8. Okay, here's my work for 7 and 8. So for 7, the sine formula was 1 minus cosine alpha over 2. I know that cosine alpha is negative 3/5. So this time, instead of 1 minus 3/5 up top, we have 1 plus. Minus negative makes positive. So I rewrite my 1 as 5 over 5. This time I'm adding 3 instead of subtracting, so I have 8/5. Keep, change, flip is 8/5 times a half. 8 over 2 simplifies to 4 over 1. Multiplying across the top is 4, across the bottom is 5. You can stop at plus or minus radical 4/5, or if you rationalize the denominator, you end up at plus or minus 2 rad 5 over 5. And then on number 8, using our tangent formula, 1 minus negative 3/5 over 1 minus 3/5. So this becomes a plus on top and a minus on bottom. Common denominators, combining, terms, keep, change, flip, simplifies to the square root of 4, which is 2. So in this problem, the radical goes away altogether.